Good afternoon, everybody. Welcome to this video. I'll be today going through the analysis and forecast for Tropical Cyclone Dikeledi. I think that's how you pronounce it. And yeah, we're going to be discussing its imminent landfall in Madagascar, its new phase in the Mozambique Channel, and more specifically, probably what it does after moving away from Mozambique, because what the Meteo France RSMC currently has right now in its latest forecast is a pretty intense kind of second peak, if you'd like to call it, after it moves away from Mozambique. In its forecast here, you can see intense tropical cyclone if you look at the legend over here. And I'm going to go through all of the kind of influences and kind of aspects which will be going on to forecasting this system over the next 5 days, what influences there will be, what things we need to really look out for to really analyze the kind of range of potential scenarios that we can really get fairly soon. So let's get to it. I'm going to first go through with the latest advisory discussion issued by Meteo France, and we can go through it and discuss it in a bit more detail. So obviously it's nearing landfall very soon. What Meteo France currently estimates is at the 10-minute maximum average wind speed. So that's 70 knots. That'll be 80 miles per hour. And they got a central pressure of 984 millibars or hectopascals, with a Dvorak analysis of 5.0, which for 1 minute estimated sustained winds is equivalent to a 90 knots estimate. But considering that Meteo France uses 10-minute estimates, we can assume that 70 knots for the time being is fairly appropriate. Let's take a look at the current structure, which can kind of suggest to us that, okay, yeah, this is a fairly not weak tropical cyclone as it nears Madagascar. It's obviously not doing the best. Its eye is struggling to clear. It's currently limited to a kind of compact central dense overcast with decent outflow cirrus going that way. As you can see, limited outflow going this way, poleward, and clearly struggling with some easterly shear as it moves westwards, but generally the impact is not as detrimental as it's moving in the direction the shear flow is currently going as well. So there is shear coming from this way, and there is some struggling going on, but some of it is mitigated against. So it's not too bad. We can currently see, again, central dense overcast, kind of compact, struggling to clear the eye. But some vortical hot towers are trying to make their way across, and it's holding itself fairly well, at least until landfall. Some of the impacts, you could probably expect some decently strong hurricane force winds, heavy rainfall, all the normal kind of stuff for a category 1 equivalent tropical cyclone. And some weakenings obviously going to be expected as it moves over Madagascar and the northern tip, really, where there will be some decent hostile terrain which will weaken the system. Now, I want to go more in depth about kind of where it's moving, why it's moving. So we're currently being steered by this subtropical ridge, and it's moving westwards with a slight nudge south, kind of in terms of direction. To go west-southwest, there's obviously this area has a weakened ridging and a strengthening troughing here potentially. And as it kind of takes this kind of direction west-southwest, it may or may not miss Mozambique. So what the GFS forecast currently has right now is a moving just overland Mozambique for a day or so before moving to emerging, and it does appear to have a weakened vortex as expected, and it will begin to move south under the influence of a second trough. So obviously it does turn south over Mozambique as a result of this first trough which passes that way, but what ends up happening afterwards is it ends up going further south, picked up more drastically as this second stronger trough picks up to its south. So that's kind of the likely situation of what's going to be happening with Dikeledi once it enters the channel in terms of movement. Now, as obviously we exit the 5-day period, we will continue to see this kind of movement south, and it will turn more easterly as well. This eastward movement, primarily steered by the subtropical ridge as that trough moves away. So there'll be less influence by that trough and probably more influence by that ridge now. But it will still try to catch up with that trough, obviously, as it retains some influence, because the influence doesn't completely go away. And that's typically where it goes. There's generally good agreement within the models. If you look here, as you can see, the European model, although there is a stronger vortex, which does lead to a larger influence by that first trough that moves by, there is still a more southward motion eventually that does happen. And with this stronger vortex, because of a stronger, better environment, we can see that it moves this way, obviously stronger influence, and it ends up reaching a pretty intense peak intensity in terms of pressure of around 949 in the central part of the channel, and it does maintain its intensity generally as it moves past Madagascar. It may struggle, depending on how that trough orientation goes, and depending on the strength of the system, we could see a skimming of Madagascar on its south side, really, as you can see there. The other models are, they're kind of split really from the point of passing near Mozambique. There is some kind of splitting between the guidance, but what I'll say is that it's the general pattern of a westward movement and then pulling by the trough to get to the south. That's generally agreed on. There's no there's little confidence going plunging straight into continental Africa. What's interesting is the Canadian, which shouldn't be taken so seriously for tropical cyclone forecasting, but it might be worth mentioning, is that it is, while obviously not being as strong as what some of the other guidance suggests, once it emerges into the channel after Madagascar, it does get pulled fairly quickly, and it actually does try to hug the coast of Madagascar as it moves south, pulled by the trough. This might be timing of the trough. Let's take a look. Let's do some comparison. Let's take a look at the 500 millibar geopotential height and anomaly. Take a look here. That ridging erodes faster when it appears to be. Yeah, it does erode faster pretty much. It's kind of what it appears to be. So even though it's a weaker system, it does still get relatively decent influence by the passing trough. Now, when I take a look at the ensemble, I think it's the various ensembles. I think it's very important that we do take a look. There is generally good agreement between the GEFS ensemble that it may go closer to Mozambique. But if we take a look at the EPS, which within its ensemble it has fairly good confidence, it takes a more easterly path. Again, we can attribute this to intensity. Now I want to go more into the intensity aspect. Let's take a look. Let's go on to the deterministic, and let's explain the environmental factors that we have. It's going to be fairly complex as it moves over Madagascar. Now I'm going to go into some of the factors first. We know that it's going to be landfalling over the northern tip, so we will see some weakening generally because of frictional effects and the basic rule that obviously tropical cyclones will weaken over land, and harsh terrain doesn't actually make it much better. It's not long that it will be over land or emerge into the channel, but it will have to deal with some after effects. First of all, knowing that this part of Madagascar typically has the most hostile terrain, it will struggle obviously with having to rebuild its core structure for a better intensification process. The better that its core is structured and aligned, the better that the vortex can intensify. Next, I'm going to go on to the GFS deterministic to present this a bit better. We can take a look here. Now, the effect of these mountains will be around for some time. Let's take a look here. Now, we're looking here at the omega profile, relative humidity profile here. The typical rule here, understanding, is that omega in its negative phases will result in rising motion. So, on its northern side of the system, at around 24 hours from the initial forecast, this will be around 18 once it emerges into the channel, we can see we'll have rising motion on the northern side. But we will have a dry air intrusion coming in, which I'll go on to going into the wind profile a bit later. It will be generally here, or let me present that a bit better, coming in from there. That will have some rising motion, in particular on the side of Madagascar. Now this will be for two reasons. Obviously we'll have dry air coming in from there, from the north side, and then two, we can take a look here and we'll see that there is a phenomenon called downsloping. And this downsloping motion, as air will obviously rise over the mountains of Madagascar, and they will obviously then have to go back down, sink on the other side of the leeward side, which would be here, closer to the system, and shown by this profile. It's also shown here, as you can see, there is a decrease in relative humidity generally in this area once the wind moves that way. You can see the wind barbs moving west and over the mountains of Madagascar, and obviously that results in lower relative humidity as the air sinks and warms. This will cause trouble in convective development, and especially with this trade wind inversion, this kind of weak trade wind inversion that we have here, we can see that there is going to be a bit of a problem for convective development after moving Madagascar. This is a common problem with systems entering the channel in their early stages, but they do eventually overcome once they've rebuilt that core structure. So it's not really going to be that big of an issue. Might be a bit of an issue in the short term, but in the long term it may be more fine. It may not be as drastic of a situation. Now, obviously, looking at steering influences, it will be moving towards Mozambique or may miss it. Obviously, we've looked through the various model scenarios and why we can see here that weakening, if it does go over Mozambique, could happen. Again, due to frictional effects, moving over the land, that will cause some problems. Once it moves into the central part of the channel, and there is good unambiguous agreement that it will move south through the central part of the channel generally, there will be some re-strengthening, very possible. This could be a third or a second peak depending on how it moves relative to Mozambique. But let's go on to the intensity prospects here. So we have a upper level anticyclone developing here, and it's within it. So it's there, and it's provided a bit of a lower shear environment, and especially moving towards the southern part of the channel, it will benefit from upper level divergence and very good upper level polar outflow as it enters and it kind of moves towards the right entrance region of the mid-latitude jet stream. And this will benefit it, and as you can see with the decreasing pressures here, there is definitely some intensification forecast here. Now, what it will need to do, and the upper level anticyclone will really benefit it in this kind of prospect, is for it to benefit most out of this upper level divergence that it might be provided with as it enters the right entrance region of the jet stream. It will have to rebuild back its core structure and its kind of mid-level structure to strengthen it, and to make sure that it's not going to be to make sure that it can handle the increase in shear as it nears obviously the jet, to benefit most out of the upper level divergence it will be provided with. So with the low shear environment after Mozambique, it will definitely be able to strengthen itself, strengthen its structure to make sure that it can handle any upcoming trough interaction. Now, this won't be an issue, especially with the European solution, where obviously it will be strengthening right as it enters the channel, essentially. They will have to rebuild its core structure. You can see that the pressure doesn't decrease so drastically right as it enters the channel, because there will be the effects of a trade wind inversion and downsloping, which will have drier intrusion effects. And it will move southwards, and obviously benefiting from initially equatorward outflow because of a large, broad upper level anticyclone that's embedded within. And then it benefits from dual channel outflow going equatorward and poleward, and it might even be close to radial if you could take a look here. Really good environment upper level wise, but it will have the impacts of potentially interacting with Madagascar on its south side, or on its southern Madagascar, because of the potential that obviously it moves south a bit too quickly, and because of its strength it will be attracted to the trough closer, essentially more stronger, due to its strength of the system, and therefore it may hit Madagascar a bit too early, and that's essentially what's forecast here. And generally what's expected as well is that we'll get a lot of weakening coming in as that vertical shear, deep layer vertical shear increases due to westerly flow that we have in the jet stream. Weakening rapidly happens, and depending on how the interaction with the trough happens, well, what it appears to be at the moment is that because it fails to interact with the trough properly, and it does take quite a while, it may struggle to begin extratropical transition, though it does still try to chase that front down. So there may be beginning signs, but it might take a while. As you can see, there are no kind of no solid connected frontal developments happening, and no frontal structure really being taken, even with it being at like 33 degrees south and very far south of Madagascar. It might take a while. It might not even happen at all. It might miss the trough completely like the GFS shows, and it may struggle with maybe a possible attempt, but then never actually completes. It ends up dissipating there in between two ridges, and it just dissipates out in the open ocean. Now I want to take a look at the wind profile, so we'll look at the various soundings that we have. Let's look at this casually. Let's see how the progression happens on it. So, currently we are seeing very noticeable easterly shear as we looked at on the satellite loop here, and this is shown in the sounding pretty clearly, that while there will be a mitigation of this shear by movement vector westwards, we see that the sounding isn't as straightforward as it as it may have been initially expected to be. We see that the shear deep layer is 25 knots and southeasterly, or just southeasterly, really, I think. And mainly we can attribute that to kind of this liner across the hodograph here. And it's not as straightforward. This is not a straightforward deep layer kind of diagram, really, presentation, where wind barbs are not exactly the same, and you have an increasing wind with height. So mid-level shear is a bit more drastic, as it will be suffering some westerly shear, with the idea that the easterly winds in the mid-levels, particularly around 700 millibars, they are weaker than the steering influence, than the speed it's moving up. So looking at it generally here, upper level going higher, which is less detrimental, is generally okay, but it does increase around 300 millibars ish. You do see that very high kind of values are there. They should not be as detrimental. What should be more concerning here in this case really is the landfall in Madagascar, which will be weakening it anyway. Now, as we move into the channel, obviously, as I've mentioned, you can see here on the relative humidity plot here that its kind of structure is a bit wrecked after passing through Madagascar, and it will have to suffer through intrusions of dry air, particularly with the idea that you do have some northeasterly flow coming, and while there is obviously the mitigation of this flow through steering influence and its movement vector, we can also analyze that there are values like 500 millibars here at 15 knots, which will be around, and will still be bringing in dry air, and it will also be around with the fact that there's a trade wind inversion over Madagascar and the downsloping effects. So there will still be convective inhibition around, despite any kind of presentation here on the hodograph, on the soundings. There will still be other behind the scene influences which will keep the system fairly weak until another potential strengthening phase. Now, as the GFS shows, the environment does improve a little bit. There will still be some shear around because of the informities kind of the kind of shear sounds that we have here, with wind vectors and directions, just wind vectors in general, not being very regular through height, which will be causing some problems. But it will be not as detrimental to prohibit strengthening, because it is clearly forecast here, and there is real potential for it. And obviously, as we discussed, again, core structure wrecked after going through Mozambique, but because of the increase of upper level divergence, it should be fine. And we can also see that the shear actually genuinely quite low, despite what the hodograph presents. We can see that overall shear is not as detrimental. It aligns with the movement vector and the upper level divergence. They all suit for some pretty suitable intensification, maybe category 1 level, judging by that pressure. Helps rebuild the core structure before the jet interaction happens because of the upper level anticyclone which is above. So as shear increases, that intensity doesn't decrease so substantially, and it does eventually weaken when it can't hold on much longer. I want to take a look at the European and the European sounding, what we kind of have here, solutions. Now, same solution here, really, same situation with the shear. It is around, there may be even soon a kind of obviously a westerly component, as the winds may be too weak, and it will have to rebuild itself once it enters the channel. But it does rebuild itself. Now the shear doesn't appear to be as it may not appear so favourable at first, but what we've got to realise here is that winds are generally it's not like they go in complete opposite directions. The kind of direction of steering and the flow in the mid-levels is generally fine, and overall the winds are quite weak, so there are no detrimental effects overall within the profile. And you've also got the upper level divergent flow that I did talk about earlier on. That's why we've got some pretty intense strengthening here, as you judge by the pressure drops there. And it does maintain that intensity overall, 950s, and then dipping down to 948. Now it does maintain intensity here, as obviously that shear, northerly in particular, does actually become detrimental. We're looking at about 25 knots at 850, 20 knots at around 700 millibars, while the steering's only 12 knots south. So that will be a bit of an effect here for now. Let's take a look at the upper level pattern which results in that. You can see here that, okay, yes, it's above an upper level anticyclone, but there are also factors like influence by the jet as it's approaching, which will begin to take a whole influence on it, or begin to have a bit of a noticeable influence on it as it approaches, as the westerlies increase. And yeah, so generally in the northern part of the channel, what we can take here, infer from the model guidance that we have, is that there is a pretty high intensity ceiling. We're looking at major equivalent category 3, maybe category 4, like Météo France is forecast. Here, I didn't actually take a look at the discussion. Pretty high intensity ceiling to develop central northern part of the channel because of a very anticyclonic and divergent environment in the upper levels, which will support an intensification. But it must organise itself quickly. Disruptions like heading over Mozambique will delay a high intensity ceiling prospect, which is why the European solution is more intense. There are no obstructions, or not, at least not as many, once it enters the channel. They get straight to the intensification process without going over land again. I want to take a look at some of the regional hurricane model solutions. Let's take a look. So look at the HWRF first. The HAFS models, I should note, the newer regional hurricane models, which have been developed by the Hurricane Research Division. They have, they've been kind of, they haven't been very consistent in terms of their performance. Sometimes they've been good, sometimes they haven't. Overall, regional hurricane models in the Southern Hemisphere haven't performed well, but I would like to see generally how their dynamics are working out here. So we're looking at the HWRF solution, and it's very similar to the GFS. It does take a while to rebuild the core structure, but then when it does have a brief intensification phase before Mozambique. It does continue to suggest that there is a favourable environment in the channel once it fixes its structure, but the ceiling will be dependent on whether obviously it wants to interact with land again or not. What's interesting here though is that its core structure doesn't actually get as wrecked as the GFS wrecks it, right, after leaving Mozambique on the HWRF. And therefore, with that structure, it is able to make the most out of the favourable environment that it will continue to have once it enters the channel again, and it does end up getting to a pretty nice peak intensity, evident by that very low pressure. So it's basically like a better GFS solution, right? It entirely depends on the core structure that it ends up getting left with after it enters the channel. Let's take a look at the half solution. Actually, we'll look at the parent view for a better view, and it's essentially it's the GFS solution. It does need to repair itself, and it does struggle after a channel. Once it enters the channel, tries to intensify before Mozambique, core structure wrecked. This might be partly because it doesn't intensify as much before Mozambique compared to the HWRF. It merges into the channel, and then essentially it is a repeat of the GFS. It just tries to intensify, and it makes the most out of the environment it has while trying to repair its core, so the intensification process becomes slowed. But it does intensify a bit later on, especially as it gets south of Madagascar, because the upper level divergence is very favourable. You can see you've got a very nice flow going that way and venting into the jet stream here. And just to show again how favourable the environment was, once it entered the channel, literally right embedded, right almost in the centre of very broad upper level anticyclonic flow. It's a very favourable environment for it to repair its core in. And when it does, it tries to make the most out of the upper divergent environment as it interacts with the trough that it's trying to get picked up by. So that's the solution. That's kind of the situation that we have here. It very depends much on if it goes into Mozambique or not. But what we do know is that it will have to repair its structure after getting over Madagascar, and it will all depend on what it does after there, where it goes exactly. But what we do know is that there is a favourable environment in the Mozambique Channel, and then however long it stays there, it will be intensifying more. We can also take a look here, more inference from the Météo France forecast. Taking essentially a blend between the regional hurricane model solutions and the GFS and the European solutions, we can kind of take a look here. That there's a bit of a blend. So it does obviously stay in the channel, it doesn't move over land, but it does try to get close to Mozambique, which this kind of solution would still be conducive to something more like an intense, long-lasting European solution, which brings higher intensity for longer, and potentially a more singular peak that's relatively strong because of its time over water. It doesn't move over land. This could potentially bring some disruption, just because there will be some land interaction as it moves close by. But considering that there's mangroves and it's relatively low lying along that piece of the coast of Mozambique, they may not have such significant of an effect, and therefore you've got strengthening forecast all the way. But yeah, this kind of track overall, considering the environment and the land that's overall involved, would lead to something more like the European solution, despite it tracking that close to Mozambique. And what I wanted to do is I wanted to take a look into the discussion in a bit more depth and see what Météo France themselves think. So obviously they agree with me with the fact that there's an embedded centre pattern with central dense overcast kind of forming. What I did actually want to take a look is, indeed, there are microwave overpass images that I do want to look through, which I mentioned, and there is easterly shear, which they also agree with. Let's take a look at the microwave overpass images that they are talking about. So let's take a look here. Obviously, we do have an attempt at a core structure with a strong vortical hot tile trying to wrap, but it doesn't end up kind of holding it. It does struggle. This is our latest image that we have. I don't think they've actually mentioned this one. This is a new image that we have with F18 pass. An attempt to hold a core structure, but it doesn't exactly do so. There is still a pretty noticeable influence of easterly shear. The bulk of the convection is stuck on the west side, which does give that away. So in terms of movement, we can see here, it's moving westwards. and it will turn west-southwest due to a slight weakness in the subtropical ridge. And there is a dispersion in the models. It does increase sharply, it does, and there will be a rapid turn eventually, depending on the level of the steering flow and the greater or less effect of a trough over southern Africa. There's a compromise between the GFS Arome, which is the mesoscale model, the French mesoscale model, or should I say the European mesoscale model, which also has a section focused around La Réunion, and the IFS models, which is the European deterministic and ensemble. Intensity, obviously we know that the lands over Madagascar will be weakening it, and the warm waters will work with the good conditions atmospherically to slowly help with intensification on Sunday, more rapidly on Monday, once it begins to benefit from that more developed, repaired core structure. And obviously, yeah, again, they mentioned that obviously there will be influence on intensity depending on the more or less significant interaction with the land of Mozambique. And significant intensification very likely with the conducive environment in the central and southern Mozambique Channel. Let's take a look at their forecast more specifically. We know that they're forecasting an intense tropical cyclone peak, but their specific intensity is 100 knots. This is 10-minute sustained forecast winds. So in terms of 1 minute, the American standard, the American 1 minute sustained winds, that would be equivalent to 150 knots. So that would be 130 miles per hour. And a Category 4 equivalent tropical cyclone in the channel. This is on the 15th. So that would be on Wednesday. Yes, Wednesday. Traffic, yeah, it is Wednesday. That'll be on Wednesday. Generally, yeah, 100 knots is what they're forecasting. Which is, it's a good baseline kind of, especially with the kind of pressures that we're seeing on the models and the kind of environment that will be conducive to allowing those pressures to get that deep with the intensification that could be happening. So yeah, that's the kind of analysis that I got for you guys today regarding Tropical Cyclone Dikeledi. I hope you guys found this very informative, and I hope you guys now have a better insight on what this environment could be like, and kind of what we could be getting within the next few days regarding this tropical cyclone. I hope you all have an amazing day, an amazing weekend. I hope everyone in the path stays safe and make sure that they get all their preparations done. There's a lot of variability in how this tropical cyclone could play out, and the ceiling and the lower bound, and generally what could happen with this tropical cyclone. There's still quite a bit of uncertainty, but I did try my best to give a bit of a best idea on what the possibilities are and what the most likely scenario could be. Thank you all for watching, hope you guys enjoyed, and yeah, I should have another video out tomorrow regarding Dikeledi again, and I'll probably be having a bit of a better discussion regarding tropical cyclones and tropical cyclone activity in the South Pacific, because this is not the only tropical cyclone that's out and about at the moment. Alright, thank you, I'll see you a lot later.